1 over f of x. Okay, so I don't want you to think it's the same as having a negative exponent. All right. So any questions on that one? Okay. I'll leave that up for a second. All right. Okay, so let's say, for example, if you wanted to determine, if, let's say, a, f of x equals x squared, b, f of x equals x cubed, are 1 to 1, if we use the inverse. Okay. So for a, whenever you have, oh, not x squared, sorry, that should have been x cubed. Okay. So for a, we know whenever you have an x squared, it's automatically not 1 to 1, because you can have a positive and negative number give you the same y value. Okay. Since two different x values can give the same y values, so for example, if you made that y equals x squared, why do I keep wanting to write that? That means that, let's say, x equals 2 will give you y equals 4, and x equals negative 2 will give you a y equals 4. Okay, so you can't have 2 and negative 2 giving you the same number, so you know it's not 1 to 1. Okay, so for B, okay, so we know that each individual x value will give you a different y value, and each individual y value will give you only one x value going to it. Okay, so if we have every x value gives a, I guess you can say, unique y value. Okay, so if you have, let's say, f of 1 equals 1 to the third, which is just 1. F of 2 equals 2 to the third, which is 8. F of 3 equals 3 to the third, which is 27, and it keeps on going. So if we try the negative numbers, we'll just get the negative of those. So f of negative 1 would just be negative 1 to the third. which is negative 26, well, negative 1, sorry. F of negative 2 is going to be negative 2 to the third, which is negative 8. And f of negative 3, which is negative 3 to the third, negative 27. It keeps on going. So we know each x value will give you one specific y value. Now, if we go the other direction, we have to see if that works. So if we apply f inverse to both sides, okay, so that means our f of 1 equals 1. Well, probably should have picked a different one, since that's both 1. So we'll try f of 2 equals 8. If we apply f inverse to both sides, the function and the inverse cancels out. So you have f inverse of 8 equals f inverse f of 2. And those two just balance right, just counter right each other out. It disappears. So we know we have f inverse of 8 equals 2. Okay. So we also have f of negative 2 equals negative 8. So if we apply f inverse to both sides, f inverse of negative 8 will give you negative 2. So f inverse of negative 8 equals the f inverse of f of negative 2. Again, they cancel each other out. So f inverse of negative 8 equals negative 2. Okay. So really what this boils down to is you have your inverse functions, and you have to find out what value of x would actually give you that y. Before you have what value, well, not value of x give you that y, but value of y will give you that x. Okay. Okay, so since each one in both directions are exactly unique, then it's 1-to-1. So f of x equals x cubed is 1-to-1. Okay. And plus, if you drew a graph of x cubed and you did the horizontal line test, that would show you it's 1-to-1. Okay, so can be shown with the horizontal line test. Okay. Remember, the vertical line test only shows if it's a function. The horizontal line test shows whether or not it's 1-to-1. All right. So any questions on that one? All right. Nobody's still writing. Okay, so what we're going to do here is we're going to find out if you have just an equation. Let's say you don't know what the graph of it looks like, so you don't know whether or not the horizontal line test will work. You're going to get that equation, and you're going to convert just a regular function into an inverse function. All right. Okay, so Okay, so the steps. Finding the inverse of a function. Okay, so your first step, you're just going to replace f of x with y. That's only if it's necessary. Okay. Now your second step is you're going to interchange all of your x and y variables. So all your x's will become y's and all your y's will become x's. X becomes y, and y becomes x. Okay. So now you're going to solve for y. And then you're going to replace that y with f inverse of x. All right. Oop, anyone's still writing? Leave it up there for a few more seconds. Oop, that was right. All right. So it'll give you the definition of an inverse function. I guess the technical definition before we keep going. Okay. So if some function f is a one-to-one function, with ordered pairs, x comma y, okay, so that means the inverse of a function f, which is, remember that's f inverse, is one-to-one with the ordered pair, clean that up a little bit, yx. So remember, it kind of switches. So instead of going for every x there's a y, now you're going for every y there's an x. Okay, so this is kind of a general definition. Oh, I'll leave that up. All right, so let's do a few examples. Oh, I'll wait a few seconds. All right. Okay, so let's say, for example, we want to determine whether each function is one-to-one. And if it is, find the inverse equation. Okay, so for A, we're going to have f of x equals 4x plus 2. And for B, we're going to use f of x equals x to the third, just to show how we're going to prove it's an inverse without relying on just plugging in random values. Okay, so here's a hint for A. Any linear function is going to be one-to-one. As long as it's not like a function that's equal to a constant. Let me make sure that's cleared up. Okay, so for example, if you have like f of x equals 4, because remember that's just a horizontal line going across. So that would fail the horizontal line test. Is automatically one-to-one because it would pass the horizontal line test. All right. So if we have f of x equals 4x plus 2, remember your first step is going to change your f of x to y. So you have y equals 4x plus 2. Okay. So your second step is you're going to switch every x with y and y with x. So you're going to switch your x and y. Okay. So instead of y equals 4x plus 2, you're going to have an x equals 4y plus 2. And your third step is you're going to solve for y. Okay, so we know that x equals 4y plus 2 means we'll have x minus 2 equals 4y, which means we'll have y equals x minus 2 over 4. Okay. So your fourth step is now you're going to replace that y with f inverse of x. So replace with f inverse of x. Okay, so we know that f inverse of x equals x minus 2 over 4. Okay, so we can see there that any x value we plug in will give us just one y value. Okay, so we know there that our function is one-to-one. So any x value of our inverse only has one output value. It is 1-to-1. Oh, sorry about that. Okay. So now we do the same thing with B. And do we have room? We should have room to put B on here. It's not that busy of a problem. Okay. So if we have B, you have f of x equals x to the third. Okay. So maybe your first step, you're going to change that to y. Y equals x to the third. Then your second step, you're going to interchange your x and y. So instead of y equals x to the third, you have x equals y to the third. Then third, you're going to solve for y. So you have the cube root on both sides. So you have y equals the cube root of x. And for your fourth step, you're going to change that to f inverse. Equals cube root of x. Okay. So you know each x value you plug in is going to have a unique f inverse value. Okay. So you can always check it if you want, because let's say if we check, okay, you just have to remember that a regular function is going to have an xy solution, and your f inverse is going to be yx. All right. So let's say if we have f of 2, remember that's 2 to the third, which is 8. And f inverse of 8 is going to be the cube root of 8, which is 2. So here, your x and y will be 2, 8, and your y and x would be 8, 2. Okay. Because remember, you did interchange your x and y's here. All right. So any questions on that one? All right. Okay. So now we're going to kind of ease back into the composite function. Because remember, when you have your composite function and your inverses kind of interacting, they cancel each other out if they're actual inverses. So if they give you two functions and they say, okay, here's a function and here's the inverse, is this the inverse of this one? You can actually check it out. Oh, oh yeah, I got a little time. Oh, I'm at 24. And something.